There are two main types of stem cells: adult stem cells and embryonic stem cells. Adult stem cells are derived from the tissues of the body. These include bone marrow, skin, heart, and many others. Embryonic stem cells are derived from blastocysts, or as defined by Junying Yu and James Thompson, quote, from embryos at a developmental stage before the time that implantation would normally occur in the uterus. So, should embryonic stem cells be used in research and in therapy? I believe that they should. My reasoning behind this is that the pluripotency of the stem cells allow for a much wider range of cells to be derived. The ESCs can really help those trying to get or are in the process of receiving donor organs, and that in vitro fertilization produces so much medical waste that could actually be donated to research. Adult stem cells are broken up into two categories: multipotent and unipotent. Multipotent stem cells are ones that can only differentiate into a few types of cells in the body, and unipotent cells are ones that can only differentiate into one type of cell. This limits the access to cells that have wide ranges to experiment on. Pluripotent stem cells, on the other hand, hold the potential for becoming virtually any cell within the body. This especially helps when trying to treat neurodegenerative diseases that have cells that are difficult to derive from adult stem cells. The organ transplant process is typically very tedious and frustrating. There's the waiting list and finding the perfect donor, and the prep process and recovery of surgery. But many usually have a hard time getting past the waiting list. According to Lucy Clark Billings of The Telegraph, as of 2015, there are 21.1 million people waiting and 469 people who had died in 2014 before they could even receive an organ. For those who do manage to find a donor, the immunosuppressants that the patient has to take prior to the surgery have their risks. The drugs work by suppressing one's immune system so much that once the organ is placed, the recipient's own body won't attack and reject it. This also increases the patient's susceptibility to simple bugs like the cold, and decreases the body's ability to ward off the infection. And even still, there's the possibility of their body rejecting the organ. As reported by Clark Billings, John Lomu, a man with a severe kidney disease, received a transplant in 2004 and lived with it until his body rejected the organ in 2011, causing the disease to resurface. He died in 2015 at age 40. The use of embryonic stem cells to create parts of or even full organs can lessen these problems. As reported by Kat McGowan of Discover magazine, quote, some 16,000 ailing Americans are waiting to receive a liver transplant, but due to the shortage of viable livers, it's likely that fewer than 7,000 transplants will be performed. In Japan, where the shortage is even worse, Takanori Takabe and colleagues started on the journey to creating livers from embryonic stem cells. With the help of two other unspecified cells, the ESCs were able to become liver cells and grow in, by which a human embryo begins to form a functioning liver. When implanted in a mouse with no functioning liver, it survived 2 months, which shows progress. ESCs could also aid in the preparation of receiving an organ. As reported in an article by Science Daily, a study done on mice showed that creating blood out of stem cells and then injecting that blood into the mouse, their, quote, T cells learn to recognize them as part of itself and therefore cause no rejection. In vitro fertilization is the fertilization of the female eggs with sperm outside of the uterus. These embryos are usually created because a couple is having difficulties becoming pregnant. The embryo is formed in a lab and then put into the uterus of the mother, where it then develops and grows into a fully functioning baby. In the lab, though, multiple embryos are formed, which means that the couple needs to decide what they want to do with those extra unused embryos. Some choose to freeze them for future use, either for themselves or to give to another couple, and some choose to discard them. The only widely accepted argument against the use of embryonic stem cells is that life begins at conception and that the destroying of an embryo is, quote, tantamount to murder. The argument is based purely on belief and has no scientific evidence to back it up. This is perceived as pretty hypocritical. Many are fine with in vitro fertilization clinics throwing out their embryos if they have no use for them anymore, but do not condone use of embryos in research for many degenerative diseases. S. Andrews of the Harvard Gazette claims that even in early arrested embryos, researchers may be able to obtain, quote, individual cells capable of growing and dividing, but ones that are further along in their development are optimal. Neonatologist Paul LaRue states that he and his team has, quote, definitely shown that those embryos that can't be used clinically are a reliable source for embryonic stem cell derivation. The donation of these embryos from IVF clinics would help immensely, especially since, according to Teresa Phillips of The Balance, under the current law, research can't be funded by the federal government unless the embryos have already been destroyed.